In previous video we have derived the expression for the components of velocity of a projectile at time t. Now we will derive the expression for components of position at time t, and also we will derive expression for the trajectory of the projectile. So let us start with the equation which we have derived in the previous video. We start with this equation which we have derived in the previous part of the video. Now this equation may be rewritten as by taking this dt on the right hand side and multiplying this m over b inside the bracket, we get expression of dr is equal to m over b inside bracket k into g plus b over m v naught e minus b over m into t multiply by dt. This dt minus I will multiply this m over b, m over b into g along k direction dt. So this is what we get is. Now let us integrate both sides. We get on integration I get r on the left hand side is equal to m over b along k this g plus b over m v naught vector e minus b over m into t multiply by this coefficient which will go in denominator on integration. So we can write minus m over b minus next term is this one. It gives me m over b g along k direction into t. So these are the values of this equation we get here. Now since it is indefinite integral, I have to put some constant here, which is, let us say, a. To find a, we use to find value of a, let at t is equal to 0 r was 0. Therefore above equation gives me m over b into k times g plus b over m v naught vector. This becomes e0 become 1. I get only minus, you can write here minus and square of it. I multiply this inside and this becomes 0 and it equal to a. So putting this value of a here, we get equation from, let us say, this equation is number 2. Equation 2 becomes with a value or is equal to, I multiply this mb term here, so I get minus m square b square into kg plus b over m v naught multiply by e minus b over m into t, this one. Then this term minus m over b g t along k direction plus the value of a. This value I have to put, that comes out to be minus m over b, this is m over b, but here this a, when this a and this negative term is on the same side, when this term goes to other side, this negative sign will become positive, so I have to put here plus, so make some correction, and then this a substitution here after this value will be positive, therefore we get m square b square into k g plus b over m v naught vector. So this is the value after substitution. Now here this term and this term is common, but this part is extra, so this equation again becomes equal to r. I take this term as common, m square b square into k g plus b over m into v naught, this term, and this is common, and inside we left with here 1 minus a minus b by m into t, then minus this term minus m over b g into t along k direction. Let us write the components of r and v naught. We get here r is equal to m square b square, inside we get k g, this k and g plus b over m. The components of v naught will be equal to along j v naught cos of theta plus along k direction v naught sine of theta, and multiply by this bracket closes here into 1 minus e minus b over m into t minus here m over b g into t k vector. Let us separate out the components I, j, k. Since there is no I component, so we will write x is equal to 0, and for y we will compare the components of j. We get here y will be equal to m square b square. From here inside we get this vector as b over m into, in bracket you can write v naught cos of theta, so this bracket closes here, multiply by 1 minus e minus b over m into t. So this is the factor we are getting, which can be simplified further, that is 1m will cancel here, so m over b into v naught cos of theta e in bracket here we will write this part in bracket. So from here we get this part only, cos theta multiply by 1 minus e minus b over m into t. Similarly, let us write the value of z from here. So we get m square over b square. In bracket we have j first term, then second term is for sine theta plus b over m v naught sine theta, and we multiply it with this factor 1 minus e minus b over m into t, this factor, then minus this m over b into g and t. So this is the factor of z. Therefore we get components of position at time t. Now to find equation of trajectory, since projectile is moving in y and z plane, so equation should be in terms of y and z. Therefore we modify equation of y. Firstly, let y is equal to m over b v naught cos of theta, this v naught cos theta, multiply by 1 minus e minus b over m into t. So from here I can find the value of this term. It gives me 1 minus e minus b over m into t. So this term comes out to be b goes the other side, y into b divided by m v naught cos of theta. So that means here I can substitute now this value, and further I can also use it. I will use it as, let us have this component as a, and then from further we can find e minus b over m into t. Further it implies t is equal to minus 1 minus yb over m v naught cos of theta. This term, one goes other side. Let us take exponential to right hand side. We get from here I left with only minus bm minus b over m into t equal to log of 1 minus yb over m v naught cos of theta, which further gives you the value of time t equal to minus m over b. It comes to right hand side, then we have log of 1 minus yb over mv naught cos of theta. Let me mark this time component as part B. Then putting these two components in the equation of z here, one a will come here and b will come here, so z equation becomes, equation of z will become now m square over b square. In bracket I have g plus b over m v naught sine theta. In bracket we get minus 1 minus e minus, oops, I have to put this value from here, therefore I will remove it and I will use it is equal to y b over mv naught cos of theta, this cos of theta from here. So in this equation I have put this value here, minus m over b g into t will come from here, so it is minus sign, a minus minus will become plus here, so we get log of inside 1 minus yb over mv naught cos of theta. Here when we put m over b and this m over b, it becomes square of the term m square and b square. Now we can use some result of log term, that using log of 1 minus x is equal to minus x minus x by 2 x square by 2 minus x cube by 3 and so on. Using this factor in this equation, we can write again z is equal to m square over b square, then g plus b over m v naught sin theta into y b over m v naught sin theta, not sin theta, it is also cos theta. Let us write down cos theta from here, plus m square over b square g into log of, now instead of this log I have to this result which we have written here, so I will write g into, let us inside bracket we will expand this portion where x is this, so I will write here minus yb over m v naught cos of theta minus y square b square over 2m square v square cos square theta minus y cube b cube over 3m cube v naught cube, here this is v naught cube cos cube theta and so on. So these terms we left with. Now I have to multiply this term inside and open the bracket, and here also we can multiply this term inside and open the bracket. We multiply m square b square here, so we get z is equal to 1m cancels here and b cancels here, so we get m into y divided by b v naught cos of theta from here. Bracket is g plus b over m v naught. Here we have sine of theta. This term is solved, plus I have to multiply this term inside. So 1b will cancel, 1m will cancel here. We will get negative term, that is minus m y into g, this g divided by, now this 1m will cancel out, that is here, but 1b will cancel out here. So again we get bv naught cos of theta. This is the first term we left with. Now in second term m square will cancel, b square will cancel, so therefore this bracket is closed, plus we get again minus term, that is b cancels, so I left with here y square, this g will be multiplied inside divided by m square will cancel, we get with 2 v naught square cos square theta. So this is our next term. Then we write third term here plus inside minus term again this one, so it is multiplied inside. Therefore we simply get b cube g and y cube divided by, oops, here we don't get b cube because 1 b square is outside, therefore I have to modify this, so it becomes b only, by cube into g, by cube into g divided by 3m v naught cube cos cube theta. So these are the terms we get after solving this equation. Now let us open this first bracket also so that terms can be made clear. We get z is equal to myg divided by bv naught cos of theta, in this g is multiplied, plus myb this over bv naught cos of theta, and naturally this m will cancel out. This m which is here, I should write this m also, into, we get here multiplied mv theta plus v naught sine of theta minus term with this myg divided by bv naught cos of theta. Then again we have minus term here, minus y square g divided by 2v naught square cos square theta minus bg y cube divided by this term 3m v naught cube cos cube theta. These are the terms on opening the brackets. Now if you compare this term with this term, these are the same but negative and positive, so you can cancel this term with this term, and we left with now all these three terms here, and in this equation v naught will cancel out and m will cancel out and b will also cancel out, so we left with only y and this. So ultimately we can write here, it implies further, here also you must write or, because we are writing the same term again. So z is equal to, from here this term I left with only y sine over cos mean tangent theta, okay, minus y square b g, y square g divided by 2v naught square cos square theta minus bgy cube divided by 3m v naught cube cos cube theta. So this is the final equation we get of the trajectory of projectile which is moving under the resistive force. In this equation we have this factor of b, and I explained in the starting that damping force is proportional to the velocity, and b comes out to be as coefficient of proportionality. Therefore this term shows the damping factor in the projectile trajectory. If suppose there is no resistive force, if there is no resistive force, then this factor will be 0, then b will be 0, and third term will be 0. Therefore, then equation of trajectory will come out to be z is equal to y tangent theta minus y square into g over 2v naught square cos square theta. And this is the equation which we also get in projectile when there is no resistive force. So this is final equation of trajectory, and if resistive force is there, this is the equation. So that's all about the motion of projectile under resistive force. Thank you for watching this video. I hope it will help you to solve the long and lengthy problem of this projectile.